You ready? All right. Ken, go ahead and introduce yourself and start the presentation.
Okay. Hi, everybody. My name's Ken. My nickname is PowerCycle. And I'm going to be talking about Metasploit, specifically scanning and pivoting. First off, about me, I usually hang out on the FNet on all the open source chat channels. My favorite is OpenWRT, which is run on this router here and a couple of the others. I highly recommend, if you're not doing anything, get involved in OpenWRT and start playing around with it. There's nothing as cheap, it's simple, it's easy to screw up and bring back to life as that. Basically, for the last 3 years, I've been a DDoS defense engineer. So I've been defending against botnets, writing firewall rules, analyzing networks, stuff like that. So I do a lot of the stuff like on the wire. A lot of the other developers are much better at the actual exploits about popping a specific box. My view of it is mostly just what's on the wire and what's on the network. So the three things I want to talk about are Nmap, DB autopwn, and pivoting. And basically, this is the scenario that any hack goes through when you're popping a box. Basically, footprinting is figuring out who you want to attack, whether it be like the Brown Hotel. You would just say, you don't even know what their IP address is, you just know where you're targeting. Scanning is figuring out who they are, what IPs they've got registered to them, what their website is, things like that. So once you get to scanning and enumeration, that's essentially what Nmap is. Nmap will only tell you what the IP address is, and it will try to figure out what service is running on that port. Nmap does not do any exploit at all. It's very focused on that. The reason I use Nmap, and a lot of people do, is it's free. It's free for personal use, it's free for commercial use. Nessus is another great scanner. It's arguably better than Nmap, but it's only free for personal use. If you try to use it in a corporate environment, it's like $1,000 per license. Nmap has a lot of scripting in it that you can try to specifically figure out if you've got a specific service that you're looking for and you want to do a specific test to test for that service. You can add scripts to Nmap. It is really, really large. But the gaining access, the escalation, the backdoor is really what Metasploit is. Really having the two things together is what works. If you don't know what you're going to exploit, if you don't know who to exploit, Metasploit won't give you anything. This is why Metasploit specifically imports Nmap data. You can Nmap from anywhere, save that file as an XML file, bring it back to your Metasploit point, and then import it. So you don't have to do the scan from the box. You can take scans that you've accumulated over a week, bring them back, load them in the database, and then try to exploit them. Okay. This is this first command is sudo nmap swoopmap for Mac, Apple, TCP trace. I won't read the whole thing right now, but this is the example of my ultimate Nmap scan. I've got these two slides here. All of these down at the bottom explain exactly what each of those options are. So I'll take some time to go through it all. First off, you want to run Nmap as the root user. If you don't run sudo Nmap or run it as root, you cannot do a stealth scan on a TCP system. The reason is a regular user is not allowed to talk directly to the interface. The root user is allowed to talk directly to the interface. The root user can override the TCP stack. If you all know what the three-way handshake is for a TCP session, you have your SYN, your SYN-ACK, then you have the ACK, then you push something, you ACK the other side, then you FIN-ACK, FIN-ACK, FIN, and you close. Any regular program that you use is not allowed to violate the TCP stack. Nmap specifically violates it so that the other system never gets a FIN. That's essentially what the -SS on there, where it says this stealth scan. if you have monitoring on the network, or specifically monitoring on that port, on that host, many monitoring software, especially if it's on the kernel itself. For instance, if it's Apache that you're running, Apache is not going to know that the port was open for port 80 if no data ever comes to the port. If no data ever comes to the port, then nothing gets logged. If nothing gets logged, then no one knows you scanned them. This is the reason you run it as root. This is also the reason when you run MSF console, you need to run sudo MSF console so that you're running as root if you run nmap from inside that. You cannot break the TCP stack unless you're root. That right there is probably the most important option. But I'll go through some of the others and tell you how and why. The first is the spoof MAC address. Nmap will let you spoof just about anything. You can spoof IP addresses. You can also spoof your MAC. And you can say, just give me a random Apple. You can say, give me a random Linux, a random Windows, or you can specify a MAC address if you want to spoof something specifically. There are some problems with this when you're scanning. I've had it work and not work, so sometimes I take it off, sometimes I don't. But it's only for the local LAN. Whoever's your DHCP server is going to be logging your MAC address. If you've got a scan and you spoof something else, then it becomes much more confusing. But basically, that's the first step. Is you want to obfuscate who you are locally. The second is a trace route. Because I do so much networking, I run a trace route on basically every IP address I analyze and look at. Nmap will include in its output the trace route to you. Here locally, because we're just one hop away from everything, it really doesn't matter. But if you're in Detroit and your target's in Dallas, it's a really good idea to know what's between you, especially the hop right before your target. Because as soon as you pop the target, you want to turn around and pivot and look at who's the router that controls that IP address? Where did he get his stuff from, and who else is that router controlling? Next one, data length 9. In an effort to hide its scan, Nmap will add extra data on the end of any packet it sends to confuse any analyzer that's trying to read those packets. The data length is how big the random bytes are on the end of it. You can set it for anything. Just from my experience, if I added 9 on it, that would fill out an entire TCP packet without making a second packet for that one scan that I was doing. The next option, -F, goes along perfectly with the data length. What I'm trying to do is fill an entire packet without going over that. But then -F cuts up those packets into 8-byte segments. It's essentially like setting your MTU to like 400. Normal MTUs are 1600s, 1500s, something like that. What you're doing is, if the IDS has profiles for the scans that you're doing, especially if you're scanning scripts, if you've got a script that scans for a particular port or something like that, you can have your IDS sit there and look for these packets that come in. If you do a -F, it's going to splice up your packets. Unless the IDS on the other side recompiles all of the packets, it's not going to see the signature. Next option, -D. These are for decoys. This is where Nmap, its ability to spoof IP addresses, comes in pretty handy. Even though you're doing a stealth send scan of the target, you're still going to try to when you find an open port, you're still going to try to verify that port. You're still going to try to verify what OS it is, other things. So there's going to be some trace that you scan the box no matter what. What the decoys allow you to do is throw a bunch of other IPs and requests at the same box so that you become one of 6 scans, or you can become one of 100 scans, basically any number you want to. What I've done here is on the first IP address where it says 200, 200, That's an example of setting an IP address. If I'm a hacker on the network and I know Brian's on the network and I want to get Brian in trouble, I can scan Adrian's server with Brian's IP address. All of the logs will show that he did it. I can come back later and do it a different way, but it's an example of how you can specify what's going on. The comma random :5 tells Metasploit to come up with 5 random IP addresses. It will not come up with private IP addresses. It will come up with real IP addresses. So when you do this, understand that the server that you hit is going to be responding to the random IP addresses. And that's probably not a good thing, especially if you keep scanning. You're going to be causing an ACK flood, basically, a really low-level ACK flood, to whoever the random targets happen to be. The next comment, it says me. If you read in the Nmap man pages on this, it basically says that on some IDSs, particularly Sun Microsystems IDS, that if it has more than 6 IP address scans, it will not record the 7th IP address. So by specifically declaring the first 6 IP addresses in the decoys and then telling Nmap put me at the 7th position, you're more likely not to be even logged if there is a logger there. The next options. -D just for most like everything else. -N. N tells Nmap not to resolve any of the IP addresses. Well, one of the things I hate is looking at a trace route where only the host name has been resolved and it's got a bunch of codes that mean something to another carrier, to another network administrator, and I don't know what the codes mean. What I really care about is the actual IP address. It's the only thing I care about. If I want to look it up later, I'll look it up, but if I'm going to run 25 scans and then come back later and look at it, it could be a month later, it could be 3 months later, the names could have changed, and I may not be able to resolve those anymore. If I just tell Nmap from the beginning, don't even worry about it, just give me these straight IPs, it's much simpler to work with. -O is for OS detection. Once you get at least 2 open ports and 1 closed port, then Nmap can figure out whether it's Linux, whether it's Apple, whether it's Microsoft, or any OS.
That -A will actually do advanced OS detection as well. So you can do more than that. It's a little bit slower, but
There's some flags that you use, like the stealth options or for, it's like throwing in decoys for make it look like Brian attacked instead of you. If you throw in the wrong options, it does actually show you as different in the logs because it does a full connection for some things. Like if you do fingerprinting, unfortunately it has to talk directly to it.
Exactly. When you're doing the stealth SIM scan, you're scanning all of the ports, but you're not opening and closing or trying to open and close all those individual ports. When you have an open port and you're trying to verify the actual service that's running on it, you have to make a full connection. You actually have to push some data to get some sort of data back. So in those cases, yes, that comes there. But if you're scanning 1,000 ports, it's better to only leave 3 pieces of evidence that you were there instead of 1,000. That's the idea.
I was thinking of you impersonating someone else, or if you were spoofing someone else, they look in the log, they'll see that his was only sends, but someone else's was full connects because they had to do the full connect to actually do the fingerprint.
Yes, exactly. Yes. So part of the point of the decoys is anticipating that somebody's going to see something. So if they're going to see something, then give them more data to just hide what's going on. So my point is just kind of get you out to a lot of the different options and you can piece together whatever is best for you. Okay. Before I go to the next slide, has anybody got any questions about these particular options? Yeah.
When you're doing the -up with fragment and the data link to do the padding on the end of that, is that using the sequence number and actually doing sequence chopping to bring it, like if you got a packet link, does it chop back the sequence number to put them back together?
It's not the sequence number. The sequence number is the packet itself.
Or yeah.
But then what the TCP stack does is whatever data you give to the TCP stack, it tries to fit it as much as it can in one packet. The size of the packet is determined by MTU, something transmission units. But whatever that size is, whatever the limit for the interface is, you don't have to send at that limit. So even though my MTU may be 1500, I can set it to 1200, I can set it to 800, I can set it to anything. So what it's doing is, when you're fragmenting, you're chopping it up into 4 pieces, you're sending them out. The interface on the other side is going to wait until all 4 packets come in, because the first 3 packets, if there's 4 slices, let's say, the first 3 packets will say, I'm a fragment, I'm a fragment, I'm a fragment. The 4th packet will say, I'm a packet. And then they'll all be reassembled, and then that service will then receive the data that was in the TCP.
Does it actually pad anything on that, though, or does it just...
Data link 9 puts extra data on that packet.
Okay, does that actually chop back the sequence numbers to bring those back together?
Dash F slices that packet. Okay? Ask your question. What was it?
So when you pad the packet, if you're padding packets, you're going to have junk data sitting in between your normal data.
Right.
Does it use the sequence numbers to try to chop those back together to do like the packet fragmentation, kind of push your data back together so you know junk data sitting or no ops or whatever?
Well, Nmap knows what's junk when it sends its stuff out, and for most of it is not even going to be. If there is a response, Nmap is not really looking for what did the service tell me. It's looking for what sort of response did I get off the port. Did I get a reset, or did I get an ACK? So the purpose of adding the extra data on there is if someone were PCAPing the network, okay, and they had a perfect flow of what went through, then reassembling all those packets in a decoder would be pretty easy. If you're adding extra data onto it, then it becomes harder for the encoder to figure out there was something here, so then the analyzers are going to try to figure out, trying to reconfigure what that data was, but there's no data, it's just random. It's mostly just a decoy again. You're not really, it doesn't do anything for the scan itself. It's just only if someone sees this scan, if they look at it, if they're watching your IP address specifically, if you're just sending a SYN and then you close a SYN and you close a SYN and you close and you never actually send any data, there's never any bulk over it, then it's pretty easy to see that it's just a scan. If there's actual data, even if it's a small amount that's in the packets, then it will at least look like it's a more legitimate transfer. So the whole reason for putting it on there is just to camouflage. So the stealth part of it is really, you're not even closing the ports properly. But when you have to send some data, like when you're trying to analyze a service and you see port 80, you're trying to figure out is it Apache or is it ISSI. When you send something there are a lot of rules which say if there's no data in the packet that comes in, then don't even allow it to get to the web server itself. So by putting something in there, you satisfy the rule of I'm trying to push some data. Let me get a response. And the web server may say this data doesn't make any sense. Tell them, I'm an ISS machine. I'm running this version. Please format your request in this. Nmap looks at the response, the error code of the response from its bogus data to figure out what's going on. And
how do you hide your IP so that you just basically have to go get on some network, just some random network, just so they wouldn't have.
You have to have a legitimate IP to receive back the information.
So you just have to go into a coffee shop or something to hide yourself. From that point of view, I guess.
Well, if you talk to Fyodor, the guy that wrote Nmap, I read a couple of his interviews. There's specifically an interview on Nmap, which he says he knows of no law which can prevent you from scanning a network. There's nothing wrong with doing Nmap or doing anything. Spoofing a bunch of IP addresses would be, not really nice, but technically there's nothing wrong with scanning.
And there's been put to somewhat of a test, though some cops may still come and talk to you and so forth. There's a guy named Scott Moulton who actually was, to my knowledge, the first person to ever have someone come after him legally because of in-mapping.
He was actually doing testing. The company was paying him, and he still ended up getting arrested. That was a few years back.
But like, for instance, if you were to go to a coffee shop and start scanning from your coffee shop, I would think there's some terms of service of using their network. I run servers in data centers, and those don't particularly they just don't have agreements for things like that because it's just commonly done. I need to test whether my firewall is up and actually working. So scanning from somewhere, you don't necessarily need to hide yourself. If you were here and you're trying to connect, you jump on the Brown network, scan everything they have, and then disconnect and maybe come back later. Come back with Metasploit from another IP address and attack from another vector. Or just exploit as quick as you can and get out. So it kind of fits on where you are. But you have to have a IP address, but you don't have to be on the same network. You just have to have access to those IPs. And what you're really trying to figure out is, if I'm in Detroit, on a server in Detroit, and I'm scanning the Brown Hotel network, what can I see from that point of view? What's accessible from outside? And then when I come in here and I scan them from inside, what's accessible from the inside? And then pivoting becomes the example of what you can come inside and then turn and then get everybody else.
Get back out again. Okay. I guess I was trying to figure out how you disassociate the IP you scanned with from the IP that you eventually connect with where you do cross that legal boundary.
That would be when you run MSF console and when you start the exploit. That is specifically attacking someone's other box maliciously.
Of course, for the sake of this class, we'd only be attacking boxes that we've been hired to do a penetration test on.
Right. But yeah, I'm just trying to understand the mindset of how you would disassociate those two IPs from each other. So you have to switch over to a different network.
Well, once you have the in-map for doing it fast and finding out what's out there, you can maybe connect through with like a Tor network or I2P or some other like darknet and connect out, or possibly move to another coffee shop, if you were so inclined to be black hat.
Right. So you just walk down the street.
But essentially, yeah.
Okay. Thanks for explaining.
Okay, some of the other stuff. Dash SS, I said the stealth sense cam. SV means that when Nmap finds an open port, is to do a version test on that port. If it finds port 22, it's going to try to figure out which version of SSH is running there. If you're running port 21, it's going to try to figure out which FTP. Usually, if you just connect and say quit, whatever service is running on that port is going to tell you outright what it's running. So it's not
like a banner drive or something like that.
Exactly. That's exactly what it is. Usually, if you tell bad information to a program, the program will tell you, "I am this." And in the logical aspect of, if you thought you were talking to an ISS server and you issued a command based on a Linux server, the ISS is not going to understand it, and its error code is going to tell you as a reminder, by the way, I'm Windows, I'm not Linux, or by the way, I'm OpenSSH, or I'm VSFTP. Okay, so it's going to do the version scan. The next one, -OA. This is the difference between Metasploit and Nmap. -OA tells I want the output, and the A says I want all of the output. There are three files that Nmap will create. One is a .nmap, one is .grep, and one is .xml. The XML is the only file that Metasploit will import, so it's the one you care about the most. For me, I just always name the name of the file, the IP address that I'm scanning. So that's what -OA on PowerSite Metasploit 192.168. All right, -- log errors. Usually you don't get anything, but if there is something in my script, I want it to go ahead and tell me what it is. And like I said, if I'm running 25 different scans of something, I don't want to have to go back on my screen to figure out what it is. I want to save the output every single time. Also, maybe cases where I rescan the same IP multiple times. So I append the output. So if it's done on Monday and I scan it again on Wednesday and I scan it again on Friday, I don't overwrite the same data or the old data, because it may be very interesting if there was no FTP port open on Tuesday and now it is open on Wednesday. The next one. Okay, -P is the ports that you want to scan. If you put a capital T and a colon in front of that, then it tells it I only want to do a TCP scan. In a lot of different cases, depending on what's going on, how you do it, the more verbose the scan, the more Nmap will try TCP, UDP, and ICMP to try to figure out what's going on. For Metasploit, you're basically going to exploit and then get a shell back to you, and then you're going to do something with that shell. That shell is going to require TCP connection. So I only want to look for TCP ports. I don't really care if there's a UDP port out there. It may be great for something else, but for actually setting up an interpreter session back to yourself, you have to have TCP, so why not only look for TCP to begin with? And here's where you declare the ports. So 1 through 1024 just says I want to do every port in that range, and then you just do commas where you can specifically add other ports. If you know you've got an exploit for 1433, or you know that your target always runs a internal proxy on 2222 or something like that. Then the last line is randomized hosts and the 2 targets that you might want to run against. Randomized hosts takes any targets that you're going to and then just alternatively picks one and does it. For this particular scan where you're declaring so many decoys, I really suggest that you don't scan an entire subnet, because with this you're going to create 7 times the amount of traffic because of the extra decoy traffic. But I wanted to put randomized hosts in just to give you an idea that if you've got a whole collection of IP addresses that you want to go through, you just got them out of a grab bag out of a box. You don't really know where to start or stop. And if someone is looking at you on the other side and you have a perfectly enumerated list of connections, then it's going to be much more obvious when somebody looks through the logs to say 1 was scanned, then 2 was scanned, then 3 was scanned, then 4 was scanned. If you just totally mix it up, it's going to be much, much harder for anyone to put together what you're doing. Okay, for Nmap, any questions about the switches options right now?
In case somebody's wondering, we're currently booting the XP box. Enough exploits hitting something, things crash, things go kablooey. So we'll be booting it so people, if they want to try some of the attacks, hopefully it'll be back up shortly. Sorry, go ahead.
All right. Okay. Inside Metasploit, the command to import a file name. So if you're doing your own Nmap command, you do -OA and you declare the output. Then here is where you can import that. So it's just a simple command, db _import _nmap _xml, and then the file name. A couple things to remember. Nmap only does the hosts and the ports, and for instance, like I said, I love to see the trace route. Metasploit doesn't include the trace route in what it imports. There's some other little extra information, such as Nmap tries to guess the operating system, and it will sometimes give you a percentage guess of what it thinks the operating system is. Metasploit, for the most part, doesn't import any of that. If it does import something, then it throws it into DB notes. Only if you import an Nmap scan do you get anything in DB notes. If you run Nmap from inside Metasploit, it doesn't put anything there with the exact same options. So here is the Nmap command, which, as you can see, it starts with db _nmap. If you're inside MFS console and you run the command this way, and I put it's the exact same options as before. But if you run db _nmap, then Metasploit will spawn the nmap, it'll do the scan for you, and it will import everything and put it into its database of hosts without having to do the extra step of import. It, as I said, only gives you the hosts and the ports, or as nmap calls them, services. And there's some extra information that's just not saved. So I like to run nmap separately and do the import. But there you go. Okay. When you import, you're going to import into a database. The first thing you need to do with Metasploit is declare what type of database you want to use. I like to use SQLite because it puts the file in the home directory. It doesn't. You don't need a SQL server or a Postgres server or anything else up and running. If you just declare SQLite 3, the file will be there on in your home directory. You can pick that file up, SCP it to another Metasploit install, import everything really quickly, and it is encrypted. If you just, when you first start Metasploit, if you just say db_create, it will create its own database. And then it'll start throwing everything in there. Or you can declare what database you want to work with. So if you have a list of Kentucky IP addresses or Kentucky targets, and you've got a different list for Ohio targets, you can keep them in completely separate databases. If you have all Windows targets in one database, Linux targets in another database, however you set it. But anyway, you just declare, give it a name. There's no passwords or anything that you need to keep up inside of Metasploit. But so it will do that all for you. So once you create the database, it's already loaded. If you exit out of Metasploit and come back into Metasploit and you've already got your database there, then all you need to declare is db_connect. That'll connect you to the default database you set up. Or if you save a specific one, you just say connect to whichever database. With SQLite, it's really easy because the databases are in the Metasploit directory. Once you've done your scan, once you've imported all of that information, now you get to look at it through the Metasploit point of view. The two most important things are DB hosts and DB services. If you just declare DB hosts, then it will show you all of the hosts that it has in its database. If it's only one, it'll show you one. If it's 100, it'll show you all 100. If you declare which IP address you want to look for, like if you're saying you want to look to see what info is on this host, then you say db_hosts space that particular IP address. And if you want options, just db_hosts space -h. Metasploit is really good about almost any command you want to run. If you just do -h, you can figure out what it is. It's the info is really tightly wound inside, so you don't have to back out to something else to read a man page or something. It's all inside the console. And then down at the bottom it says available columns. That is all the different information that it's basically pulling from nmap and then telling you, so that you can sort. If you've done a scan, you didn't know which ones were Windows boxes or which ones were Linux. You can sort your database right here by just saying -c and then specifying the column, lots of different stuff. db_services is the ports that are open on the hosts that you scanned. So if I say DB services on this IP address, it's going to tell me the 5, 7, or however many ports you have open. It's also going to tell you what vulnerabilities line up to the ports that are open. So if you have anything that's exploitable that you've already scanned. So once you've done the scan and you want to exploit the box, this is where DB Autopwn comes into play. These are the options for select the vulnerabilities scanned by the ports that are open, tell you everything that's running, actually exploit it, and then the -R is for making a reverse shell connect back to you. -I declares specifically which host you want to exploit. If you have a database of 100 hosts and you don't specify an IP address, then it will try to exploit every single host in your database. If your own host happens to be in there, then you can specify X or exclude this particular IP.
There's also a new feature too for rankings. It's like based off of an exploit. Like for example, when you're doing mass ownage of a system, there's different category rankings. So you either have like bad, good, or excellent based off of maybe like a done out service or the exploit's kind of shaky and crash the service. You can actually do like an excellent ranking, so it only fire off exploits that things won't crash the service or down something, which is pretty nice.
Also, I kind of want to mention here, DB Autopwn is not really the best way for Metasploit to pop a box. It's much better if you know a specific vulnerability on the server you're running at. It's much more, it's much less obvious and it's much more sneaky just to run a single exploit and get in. The idea behind DB Autopwn and the idea behind Metasploit is it's a framework. So in the context of the framework, all of the exploits are loaded in there, and you just, as a dumb script kiddie, just run it. You don't really have to think about what vulnerabilities are open. If you scan and then you run against it, that's all it is. You don't have to know how to get in the box. DB Autopwn it's running so much at the same time. Like he said, it can really overwhelm the box and overwhelm particular servers. So my point in showing you this is just kind of of what Metasploit actually is. Metasploit can be. If you think back to I think it was the Melissa virus that was released about 10 years ago or something like that. It was actually written in, I think, 30 minutes. Some guy had been to a strip club, I think, came home, downloaded a virus creator, some virus creator software, and then named it after the stripper he just seen.
I hated when I get a virus after getting back from a strip club.
And then literally within 30 minutes of creating it and then releasing it, it owned the entire internet. He didn't mean for it to get back that big. He had no idea what he was even really doing. And that's kind of what I wanted to demonstrate is you don't even have to really know how the exploit works or why the exploit works, because Metasploit as a framework allows you to swing back and forth to the parts you do know. If you can get to this point and run this exploit, then you can just keep running and keep running and keep running, and it doesn't matter. If you've got a server out there, you can run all day long. You can have Nmap continually coming up with random IP addresses to scan, and you can have DB Autopwn continually sitting there trying to own every IP that comes up. This, for me, was the most awesome thing about Metasploit. There have always been exploits and scripts and different ways of exploiting a box or a particular service. And with Metasploit being a framework, it's perfect because you don't have to know each individual step. You don't have to hardwire or change your variables or whatever to get your specific thing working. You just load the exploits. Every week, almost every day, there are new exploits coming out. So you don't even have to know what they are. If you just run Autopwn, every exploit that you have loaded and downloaded is going to try to hit that target. Any questions? third thing I wanted to talk about was pivoting. In a networking concept, when you exploit a particular box, there's a chance that that box is going to be able to talk to other boxes that you can't connect to. If you're coming in from the outside of a firewall and you get a reverse shell from one particular IP address, and let me say there are lots of different ways to exploit somebody. One way might be like a USB key, where you give somebody, they plug it in, they take their laptop back into the company, open it up, and then that exploit then connects back to you. Unless he connected back to you, there would be no way to get inside the firewall to get to him. Since he's talking to you, this internal computer has access and can probably see everybody else in their network. So what Metasploit allows you to do is pivot your scans and your exploits from the one internal box you have against everyone else, because you can't talk to any of those boxes externally. So once you get a interpreter command line, no matter how you get it, whether it be social engineering, an actual direct exploit off of it, if you run the script get local subnets, then it'll tell you what it can see. Usually it's going to be some private IP address if it's going to be in some corporate environment. So if you then background that session, go to your MFS console and add a route for the new subnet that you just saw on the box you popped, then any scans you do on that internal subnet will be routed through the box you've already have. So from your you asked earlier about the IP address that the scans are coming from. If you exploit a box internally and then you're basically doing a proxy. When you do your scans internally now from this other box, that's the box that's going to show up in all the logs. So it's very easy now. Once you're in this interpreter session, once you're in the MFS console, and you're going to do an nmap scan, you would have to do db_nmap in order to be routed through the pivot machine. Any questions? This was the other thing, and this is the last thing I was going to talk about for some other stuff, some demonstrations like screen if you want. But just this February, Egypt, who's a Metasploit dev, did a presentation at Black Hat DC about automatically routing through new subnets. The thing I loved about DB Autopilot is you don't have to think about it. But once you pop that box, then you had to manually go through and enter the new route that you just found. So he created a script called auto add route, which you can just add with load auto route, so that when you pop a box, it will automatically add that route to Metasploit. So if you have 25 machines on 25 different IP addresses, then you could cycle through all of them. You could be automatically scanning, automatically pwning, automatically adding the route, and then having more IP addresses to scan again. And it becomes a very simple, dumb loop where you don't even have to know the IP addresses. You just have to start it off and get lucky with one. Basically, it's just a route print at the end. We'll show you what your routes are if you've added anything. So that's it for all my commands and switches. Let's see. This is what DB host looks like. It just gives you the IP address addresses and only the IP addresses with the ones you've scanned. Here's all of the services, and then over in this last column, I'm going to show you what IP address is associated to it. Like I said, if you've got hundreds of IPs in your database, then you just limit it by the IP address or by the port, whatever you like. What you're looking at here down at the bottom is what happens when Nmap runs its scan. If you look, it's going through and hitting each port in my list. And I think it's if you look at this, you stop this real quick. For instance, this right here, you see these options that Nmap is sending to port 135 on 128. It's giving it headers that should be applicable to a submachine or it's giving it bad info. Basically, you can see where it says branch foo and tag root and 42 options, things like that. That should mean nothing to the service that's running on the other side. That's not the bogus data link. This is part of the scripting to figure out what the version is. But as it's going through, this is the sort of stuff that the IDSs are going to be looking for. So the more you can cut it up, that's a pretty small packet to begin with. But this help. A lot of this stuff is just Nmap going back and forth, so I don't want to go into too much of it, but that's basically the Metasploit stuff. I'll tell you a bit about Screen real quick. Okay. Screen is my favorite program of all time. It's a terminal multiplexer that allows you to have multiple terminals running inside the same terminal program. So I can split, I can have up to about 24 different sessions running at the same time off the same box within the same window, so you don't have to alt-tab through all the different stuff. One of the best things about it is the buffer. So if I switch off to a different screen, then you can scroll back with inside that screen's buffer. So I think this is set at like 500 right now. But like you were talking about, more or less. So if I go to
yeah, like I was wanting to easily be able to go up. I want to be able to type like help in Metasploit and be able to scroll up easily to the stuff above, or better yet, just have it show me one screen at a time and hit enter the page through them or something.
Yeah, I don't know how to do one screen at a time, but like if I do help here, screen will let me scroll back very easily to get into it.
Okay.
And it's just a Control A escape that gets you into the scroll back buffer, and then up and down work, page up and page down work. You can do a reverse search, and it will search up. So if you know a particular word on the line you're looking for, you can look for it that way. I've had screen sessions with history that is as long as 10,000 lines. So it can be much more than your visual browser would ever want to keep track of. And the thing about the buffer is once you close the screen and it's gone, it doesn't really need to log any of it, but it's so far back I've had sessions go on for days. And if you just never close the screen session and go back to it, you can scroll back and see what went on. If it's small amounts of packets, less than 10,000 whatever, then you can scroll back and see, it'll include all the timestamps, it'll include everything. So it's really easy. And with the search option, it's really easy to go up and down and figure out, as long as you know what you're looking for, you can jump directly to it and then just page down from there.
Okay.
Okay. Any questions? Anything over anything I already talked about?